All right, thank you. Yeah, so I'm going to talk about a little bit different topic here, creating beautiful interactive maps with R and JavaScript D3. Like Rebecca said, my name's Henry Beimers. I'm a data analyst at NORC at the University of Chicago. If you don't know it, NORC is one of the largest social science research organizations in the US. It originally stood for National Opinion Research Center, but now we do a lot of other research, especially in the public health sphere with universities and other nonprofits. We also run the General Social Survey and do political polling for the Associated Press. So in the presentation here today, I'll be walking through why R and D3, the JavaScript library, are excellent open source tools for mapping your spatial data. So if you don't know it, R is a programming language designed for statistics and data analysis, and what it's really excellent at is data ingestion and transformation. JavaScript, on the other hand, is the essential language for any interactivity on the web. D3 is a JavaScript library for interactive data visualization, and that was created by Mike Bostock, who was known for graphics, working on graphics at the New York Times. The R2D3 R package takes advantage of both the powerful data processing available in R, as well as the extreme flexibility of the JavaScript D3 library. So the data is held within R and then eventually passed to JavaScript D3 to create your visualization. And I want to emphasize that everything I'm touching on today is free and open source. There's a ton of documentation online and a ton of examples, and I'd really encourage everyone to download R and give it a try. So these are just a few examples of the many things that D3 can do. These are from observablehq.com. D3 is extremely customizable. There are essentially 0 defaults, and that is actually one of its biggest advantages. So you basically have to tell it to do a lot, but it can do nearly anything that you want. I'm just going to touch on quickly a couple other ways to create maps in R. So R2D3 is great for interactive maps, but for static maps, ggplot2 is kind of the standard. As a caveat, it is really difficult to use to make a high-quality product, but it is great for quick and dirty static maps and other data viz. For interactive maps in R, you also have Leaflet, which is originally a JavaScript library, but there's an excellent R package for it as well. To quickly compare D3 and Leaflet, D3 is really adaptable, where Leaflet is more specialized for traditional mapping. So Leaflet takes advantage of things like base maps, pop-ups, and tooltips, and D3 is much more data-driven. So you're looking at things like choropleth and heat maps as more of the advantage there. So the output of D3 is an SVG, a scalable vector graphic, and the scalable element of that is what's really important here. It's really great for 508 compliance. It can fit anywhere, including on a mobile device. You can also save the outputs as standalone HTML files, so something you could just double-click to open or embed elsewhere. So the primary example I want to walk us through today is a common cartographic task that I encounter in my day-to-day work. Often when conducting surveys, we'll use administrative data to append to a survey frame, to maybe target a specific demographic group for a survey, or to supplement survey results. In this case, we're going to use some Census Bureau data. We'll only need to import these 4 R libraries to create the interactive map. Just to go through them really quick. Tidyverse is the most popular R package. It's very similar to Python's pandas, if you're familiar with it, and it's primarily oriented towards transforming data. TidyCensus is an R wrapper for the Census API. It's an amazing library. It deserves its own talk. And the SF package allows R to work with spatial data like shapefiles, GeoJSONs, and is based on GDAL. So on the R data prep side, in this code block that you can see, we start by using this get ACS function from the TidyCensus package. So this In here, we're using the parameters for the geography as census block group. Variable is the variable for median home value from the ACS, state Washington, county Pierce, and we want geometry along with it. You can also choose to not include the geometry if you just want a table of the data. So this first line is highlighting that we're doing that at the block group level. On line 9, doing the same thing at the track level, just changing that one parameter, and then using this function to bind all of the data together. And the output you can see here on the right side in this table, we've got 811 rows for all of these block groups and tracks in Pierce County. Yeah, and just these few variables to classify them in the map. So in under 20 lines of code, all your data prep is done. Here is the R2D3 function from the R2D3 package, and I'll just highlight these few lines, which are all you really need to run the visualization. The rest is just from the RShiny package, which is a package for building websites in R, and I've included that in the presentation just to show how the data viz can react to inputs in real time. So for R2D3 to work, you need your input data table from R, which is called all_data, a file path to your D3 script, which is saved in the same directory that you're working in, and some user-defined options, which can be passed to the script. So under this list of options, you can pass any R variable as an option to R2D3. One of the ways that I commonly use them is to pass other data sets, so you can basically create different layers that way. So here we got the map. So these two drop-down lists at the top control the user-defined options in the script. So these can alter the level of geography we want to see. Right now we're looking at the tracks, but if you select CBG, it just transforms them to the census block group level. And this drop-down just changes the color of the NA values, just to show how the graphic can quickly react to inputs from R. And I've also added some zoom and pan and tooltip functionality, just to show these D3 elements that are really basic, but are really useful for cartography. By the way, I also made this slideshow in Quarto, which is an R publishing system, which is how I've been able to add this interactivity to the slides, which is a lot of fun. And this is a big block of JavaScript, but I'm just going to quickly highlight some important parts just to look under the hood a little bit. So this first line is removing any previously rendered graphics. So otherwise, the SVGs will just stack on top of each other after every time you change a selection in the dropdown or some other input. G just stands for group and is kind of the base unit when you're working in JavaScript D3. Next is this data transformation. So when R passes a data frame to D3 through R2D3, it comes out in this sort of weird column formatting. And this just transforms the data into more of a row-wise format, which is much easier to map within D3. And as you can see on line 8, there is this filter that is using our input from the geography dropdown to filter the data to the level that we want. Next, the projection is defined using this convenience function from D3 based on the width and the height of the element. And then our path is defined so that the map can be drawn. We also wanted to create a variable for the color scale. I used the blues palette from Color Brewer, and all of those come with D3 by default for your choropleth mapping. And then here's where the map is actually drawn, calling the palette variable with the estimated median home value from the data to show the color on the polygons. The rest of the code here in this code block is the functionality for the zoom and pan and tooltip, but everything that I've just highlighted is all you need for a basic map. And this could be a whole other topic for another presentation, but the D3 script can actually talk back to R. So if you click on a map element, you can get that value back into R. So if you're building a dashboard, that can control other filters or other tables on your page. So because D3 is based on vector graphics, maps using vector data are much more highly favored. However, there are some nice ways to use raster data as well. This is just an example I quickly made using a digital elevation model based around Pierce County as well. And this data prep as well was probably like 8 lines within R. They're great R packages for just pulling raster data quickly, especially using census geographies as your bounding area. So I transformed that raster data into contour lines using the D3 contour function. Something that you could easily do in the user-defined options in R2D3 is to have a value that could be on a slider that can alter the density of the lines, like you can see here, or just change the color. Finally, I'll show a couple examples of projects where I've used R2D3 in my work at NORC. It's great for things like this live crime tracker site, which is built entirely out of R-Shiny, where we need to update the data on a daily basis with data from dozens of cities. So those data are categorized completely differently depending on the city they're coming from. They're in different formats. So all of that data transformation is happening in R. And then it's visualized with this D3 map. I also used R2D3 in this dashboard, which is like the example from Pierce County, but scaled up 100 times. In recent years, we've made a lot of dashboards like this for exploring different social determinants of health for public health projects, especially for rural areas. And again, the user controls those options with those filters and the overlays on the sidebar for the data in R, and it's just this map that is being produced in D3. So at the end of the slides here, I've included some links to some resources I found helpful in my D3 journey and my journey with R. Again, there's a lot more resources and examples out there, and a ton of public data, and anyone can really start to make their own customizable maps this way with these free and open source software tools. Thank you. That's all I have.
Yes.
I wonder if you could please try the interactivity on slide 10 again.
Yeah.
Yeah, don't think we can see.
Oh, you couldn't see it. Okay. Oh, wait. Yeah. I thought it would, I was doing it on this speaker. Okay. Yeah, so there's just these tooltips and highlighting. Yeah, and then if you change the values in the drop-down, changes the colors. Obviously, there are a ton of customizations you can do to make this styled however you want. But yeah, this is just a fun example that I thought I'd share. Yeah.
Any other? Yes.
I was wondering, have you explored, are you able to tie the change in geographic units to something like changing the zoom scale so that it can be scrollable as opposed to like using the drop-down filters?
I think I know what you mean. But yes, like, do you mean like where if you change the geography, the zoom level changes?
Rather than using the drop-down to change between block groups and census tracts, that
Oh.
it changes from census tracts to the block group.
I actually haven't done that, but I imagine it's possible. There are tons of things you can do, like, for example, if you select something from the drop-down, it'll zoom to an area. So actually, that's a great thing I should think about looking into.
And I'll take a moment to ask a question that I'm curious about. I always like to hear folks' origin stories for how they either stumble upon R or are introduced to R, because
Yeah.
it seems to be different for every person.
Yeah, so I only started working with R less than 2 years ago, and JavaScript D3 even less than that. So basically, I just started when I started this job. Before that, I didn't know any R. But
Well,
that's
this is
what
also
we were
a
doing.
sign of it's been 2 years and you're accomplishing a lot of really neat things.
Yeah.
So it's a great inspiration for others to try. All right, everyone, let's give it up for Henry.
Thanks.